All right, so let's take a look at some of these problems that we did. All right, so for this one, we're asked to find the value of x, and so we're supposed to look at this and say, okay, I know this angle and this angle are the same, and this angle and this angle are the same. These two sides are the same, therefore all triangulos are the same. So since this is 7 feet, then this also has to be 7 feet. So that means that x equals 3. All right, then over to here. I know that these two angles are the same. I don't feel like technically we can solve this one because I could take this triangle and stretch it out in a way that these two are not necessarily equal. Well, I guess this may be a mistake on the part of the textbook because, like I said, angle, angle, angle is not one, and we can't solve this for x by assuming that they're equal. We know that this angle and that angle are equal, but we always need at least one side to show that triangles are congruent. So I'm going to say you can't actually do that, but if you could, then x would equal 4. Okay, state whether the triangles are congruent and by which theorem. So we've got angle, angle, side, and we've got angle, angle, side. So that would be angle, angle, side. And then this is angle, side, angle, angle, side, angle. So that is, therefore, angle, side, angle. Yay! Okay, how would we know that these two quadrilaterals are congruent when we've had no conversations about proving quadrilaterals congruent? Well, we can take and make these into triangles. And then I know that this triangle here is congruent to that triangle there by side, angle, side, side, angle, side. Likewise with this guy down here, these two things would be congruent by side, angle, side, side, angle, side. And then that means that everybody is the same. So yeah, there you go. How might you decide what additional piece of information you need to prove that JKL is congruent to NOM? Well, like I said before, you always need at least one side to show that two triangles are congruent. Words of wisdom. So it would not be enough to say that angle L is congruent to angle M, but any side will do. We only need one if we have two angles. So I could say, if I know that this angle and this angle are congruent, then I'm good by angle, side, angle. If I wanted to be wacky McCracky, I could say if I know that this angle or that side and that side are the same, then I'm good by angle, angle, side. Or I could slide on over here and show that those two are, if those two are congruent, then I get it again by angle, angle, side. So how might I decide which I need? It would depend on the information that was given to me, and then I would decide. Okay, we talked about this with the tower in the notes. If that's 90 degrees, then that's also 90 degrees. This is congruent to itself. So obviously if those two angles are the same, then those two side beams are the same. Durr. Okay, so I threw a couple proofs in here just because every once in a while proofs happen, so you should be ready for it. So we have this given information. So this is silly because we already have it, but you would like to, so this is, I'm sorry, proving the angle, angle, side. So we can't use angle, angle, side because that's what we're trying to prove. Okay, so we know that angle P is congruent to angle, angle S. Likewise, we know angle Q is congruent to angle T, and that is given. I just threw those two sides, or two angles in there together. I probably could have thrown the sides in there also, but we'll just do that now. Nope, I'm not going to do that now. I'm going to say that therefore angle, we talked about this already, angle U is congruent to angle R, and that is because they add up to 180 degrees. I might want to flesh that out a little bit. And then therefore, since I know that QR is congruent to TU, that was also given to us, then I know that triangle PQR is congruent to triangle STU by, what did I just do? Angle side angle. There you go. So, like I said when we were going through the notes, the reason why angle side works is because if you have two angles, then really you get the third angle for free. And then once you get that third angle, you can go angle side angle. Okay, crows, proofs. Mom said, hey, proofs. Why do you make us do proofs? All right, so we know that A is congruent to C. That's given. We know BX is congruent to DX. That's also given. For some reason, you always have to write those down. Let's see. Then I also know that angle BXC is congruent to angle DXA because they're vertical angles. Now I have, so I got this guy right here. So that looks like I'm all set up for angle side. Oops, they weren't up there. Oh, really? No, not me. You're talking to you. There we go. Okay, so now I know that triangle AXB is congruent to triangle CXB, and that would be by angle side. And therefore, AX is congruent to CX by CPCTC. Corresponding parts of congruent triangles are congruent. Please not another proof. Okay. All right. Is ABCD congruent to that? Let's see. I know this. Angle side, and I got an angle side. So those match up. Since those match up, corresponding parts are congruent. So that means that this is congruent to that. And since I know that these two things are congruent, I got myself a side angle side situation. So these two triangles are also congruent. And since both little pieces are congruent, the whole thing must be congruent. All right. And then last one, if ABCD is congruent to EFGH, are all corresponding parts congruent? Yeah, seems like it because you can divide it up into two triangles. And since the pieces of the triangles are congruent, that means the pieces of the quadrilaterals will be congruent